Great careers are not accidents, they're journeys built through clarity and intent. In every industry, there are such journeys that reveal true leadership, sacrifice, risk, and purpose. I'm Dirk Horn, and this is The Pitch and the Catch, where we dive into choices, changes, and the careers they create. Welcome. Back in February, we had Jim VanderGiessen, CEO of Pro Refrigeration, on The Pitch and the Catch. What stood out immediately was how intentional they are about building systems that don't just perform, but create value above and beyond customer expectations. A few weeks later, we had the chance to visit Jim and his team in Tulare, California at the World Ag Expo. What you're about to see is a walkthrough with Jim's son, John, who takes us inside one of their newest systems. And what I love about this, it's not just about cooling, which I have to admit I'm not an expert on, but what I know about is passion, energy, and system thinking. On the technological side of things, you'll see how they capture waste heat and turn it into usable energy. For example, for heating water on dairy farms, instead of letting that energy just disappear. And just as importantly, the breakthrough thinking, how they're connecting these systems through IoT, giving customers real-time visibility and ultimate control over their own operations. It's a great example of what happens when passion, determination, and engineering meet customer thinking. Let's take a look.
Nice to meet you. Thanks for being a guest here. So what are we looking at?
So this is our Quad 40 design. So this has 40 horsepower bitzers, and they're all independent circuits. So you've got 4 independent 40 horsepower circuits with a total of...
So it's like a 2-cylinder engine, or 3-cylinder engine.
Mm-hmm.
Okay, very nice. So who builds those engines?
Bitzer.
Okay, that's Bitzer.
Yeah.
So what does it basically do? So so on what fuel does it run?
So it's on refrigerant. So this is
refrigerant.
Yes, this is
oh my gosh, yes.
54C. So this is an A2L. So it's a lower GWP.
You got to give me layman's terms, man.
Yeah. So with the regulations in the U.S., they've been limiting the GWP allowance on the refrigerants. So this is one with it's got to be below 150 GWP.
Okay.
So it's better for the environment, and so that's what we're running as.
Okay. Understood.
Yep.
Okay. So this is underneath. This is where where it's being moved, basically. What happens up there?
So up here, so off of this compressor, you've got discharge gas. So this is going to be a very hot refrigerant gas coming out of the top, being discharged from the compressor. And what we're doing with these heat exchangers is we're capturing that heat. So we've got an enclosed hot glycol loop going through here, and we're able to strip that heat off of that discharge gas and cool and heat their water at the plant. So if it's at a dairy farm, we're able to get their hot water tank up to 150 degrees.
Okay.
That way they're not having to heat it themselves with their natural gas or propane.
Understood.
They can just get it from 150 to 170 with their gas, but we can get it to 150 with the chiller.
Okay, so why would they want hot water? Just to clean the tanks?
Dairy farms, once they go through a milk shift, once they're done milking all the cows, they're going to follow up with the chemical wash of a hot water with the chemical to clean their milk tanks.
Okay, so that's a cleaning process.
Correct.
Yeah.
So we just help them get that hot water and save them a bunch.
But you're Pro Refrigeration, not Pro your chiller systems. But no, that sounds like doesn't sound like chilling things. It sounds like heating things up.
Yeah, we won't putting that waste heat up into the air.
Yeah,
we'd rather capture
you're
it
using
and utilize it.
Yeah, that makes a lot of sense.
Yeah.
So who would buy a unit like this?
So this would be for a dairy farm. It could be for a brewery. It kind of could be for anywhere, a winery. This is a pretty big scale. This is quite a bit of horsepower. So it'd be on a farm with maybe 3,500 to 4,000 cows. So pretty big.
So
big
much
farm.
more than I got used. We had 60 cows.
Okay.
Yeah, that was cute. I know it was cute.
Yeah, but we focus. So this one's for a low ambient. So we've got receiver heaters. So this pressure switch you're seeing here.
Yes.
So that's to energize the receiver heater. So for low ambient, this is going to Idaho. So for their cold winters, this is going to help keep everything running even during the cold ambient.
Nice. Oh, so that is basically you sold that unit. So that's a customer's unit?
It's going straight from here to
straight from. Oh, that is smart.
Yeah.
That is smart. Okay, so did they come here to look at it first, or do they?
Yeah, the owner of the dairy farm is going to be by this afternoon.
Oh, here we go. So you're like, here it is.
Yeah,
shall we wrap it up for you?
Yeah, I wish we could do that. They don't have the power for us here to do that, but that would be very cool. But yeah, so and then on the fluid side of things, we like to focus a lot on, like to have backup, especially at a dairy farm.
That's different.
So we've got backup pumps for everything. So especially a lot of these farms are very remote.
Yes.
It takes 2 to 3 days to get a new pump. If you see,
So it's basically redundancy. That's the
exactly.
So that they have no downtime.
Exactly. And we do that same with the compressor. So
Yeah.
when we size one of these units, we size it for, if it's a 4 compressor unit, we want 3 compressors to handle that whole load.
Yes.
And then that 4th circuit is a full redundant.
Very nice.
And then same with the pumps. This is the process
I like
pump
the
here.
pump.
Yeah, so this pump feeds their plate cooler, which is what you'll see over there. So it's what actually sends the cold glycol to the plate cooler to instant cool the milk. So there's a backup pump for that, just by a flip of a switch. If that pump goes down, they can just turn the back up and it's their backup.
So, and I'm sorry for asking a stupid question. So this unit heats and cools. So there's a circuit in there. How because we're talking about heating water and now we're talking about
so the primary focus is cooling the glycol. And then one of the byproducts of cooling is also making hot water.
Making hot water because you get the heat.
Taking advantage of that.
Yes.
Yep.
You're basically taking the heat out of the milk. And using it to clean afterwards. This is actually very smart.
Yeah. Otherwise, we're just putting, like, when the system's running, if you're on top of those fans, you've got hot air running out.
Oh, I can imagine.
And it's all that energy we're just putting up into there.
Yeah.
We'd rather strip as much as we can.
Nice.
Put it to
very resourceful.
Put it to their water.
So once this thing is up and running, how often do you need to maintain it? Or
I would say probably twice a year.
Twice a year.
Yeah. You've got a bunch of starters.
So what would be a place that needs most maintenance? I mean, a compressor could probably run forever, I assume.
Yeah. I'll open one of these up and we can go over that. It's in these sub panels. Yeah. So this is kind of the brains of the operation. So there's going to be one of these panels above each of the 4 compressors. So you got your circuit breakers.
Yep.
Feeding the high voltage power. This is for the fans here.
Yep.
So those are going up to EC motors up top. So they're on variable speed drives. And then you've got your starter for the compressor.
So I got to ask, can you put this thing online? It can be maintained online. You can go in, see what the problem is. Everybody wants to be online these days.
You want to go check that out?
I don't get. Here we go.
So this is currently live right now. So these are all farms and our customers.
Jersey Land Farms in Wisconsin.
So we can view it. So this is a 2 compressor system.
No way.
Yeah, right now circuit 2
This is live.
This is live.
That's very cool.
Yeah. We can go through and graph historical data. I can see system data. I can view pressures. A lot of the times, because I'm more on the technician side.
Yes.
So a lot of the times I can call the tech that's heading out to the dairy farm. I can be like, here's what you got going on. You got a bad temp sensor here. They can make sure they got it at the truck before.
You're in Bloomfield, New Jersey. It's like half an hour from where we live.
Also brewery. Yeah, you should go check that out.
Yeah, Heritage Brewery. That is kind of funny.
Yeah. They got one circuit there and they're satisfied because they're only 0.9 degrees above set point. So
okay. Set point parameters. This is beautiful. So, and this is why you're monitoring this. So, in terms of call the customer when you see a problem, or what's the driver for that?
On our tech support end, we monitor it on a daily basis.
Yes,
so we have a guy that's always at his computer watching this data live.
Okay,
and we have a list of contact information for these customers. We'll reach out and let them know.
And is that a service you sell? Is like because we're watching over your system?
It comes standard with every system. And then we offer a continued basis if the customer chooses to do it. So
that's very cool.
Yeah.
Very cool. On Idaho, Wisconsin, you're everywhere.
Yeah.
Kansas. This is good.
Yeah.
Colorado. Nice. Thanks for showing.
Got a couple low tech ones here.
Oh, so what does that mean?
So it's for an extraction. So for like a CBD or something like that, it'll.
Oh yeah. Of course.
Yeah.
Tampa. Is this Florida?
Yeah.
Yeah. Really cool. Exciting.
What struck me here is how simple the idea is and how powerful the impact becomes. You take something every system produces, like heat, data, signals, and instead of losing it, you turn it into value for the customer. That's the shift we talk about all the time. From product to system, from system to insight, and ultimately to partnership. Huge thanks to Jim, John, and the entire Pro Refrigeration team for having us. We hope you enjoyed this episode. Don't forget to like and subscribe. See you next time on The Pitch and the Catch.